All right, welcome back. This is going to be the continuation of the Unit 8 notes, Unit 8 being aquatic and terrestrial pollution. In this video, we're going to be looking at Section 8 from Unit 8, Biomagnification and Bioaccumulation. We'll look at the difference between these two and why they are so important. So bioaccumulation is just an increase in a concentration of a pollutant in a single organism, okay? Biomagnification is where we're looking at the increase in concentration of a pollutant in a food chain, because as small amounts will exist in smaller species, as you move up in the food chain, they biomagnify because those species eat many of the smaller species. So another really good example here is bioaccumulation. Over time, this species will accumulate more and more of that pollutant, whereas biomagnification, small amounts in small species will be eaten by species in the food chain up, which creates a higher level of that pollutant. And as you keep going up, you get more of that pollutant level. So by the time you get to the apex of that food chain, you're going to see higher levels of that pollutant, which is biomagnification. Now, a case study for this is looking at top carnivores, and this was actually a case study that was done in the wonderful book Silent Spring. And Silent Spring brought a huge amount of awareness to the use of pesticides like DDT, which were thinning eggshells and causing reproductive malformities in peregrine falcons. This was also affecting the bald eagle, and so essentially when you had large amounts of DDT found in those top predators, because the DDT was being taken in by smaller species, and as you traveled up the food chain, you got more and more higher and higher levels, which were causing a drastic decrease in the population of these top carnivores. Now, it's important for us to keep in mind that we are technically the apex species. Most of these species we will eventually eat. So in this example, phytoplankton, there's not a whole lot of the levels of pollution in the phytoplankton, but because there are so many phytoplankton being eaten by less shrimp, that is where you start to see a biomagnification in the shrimp. Then shrimp are eaten by, in this example, I can't even quite see what that says, white creeker? I don't know. But a larger species of fish that is eating the shrimp. So now you're getting a higher magnification because they eat many of the shrimp. Then salmon eat those smaller fish to create that, to sustain themselves, and we eventually eat the salmon. So we're getting higher levels of that toxin, even though we're not eating, say, the phytoplankton. That biomagnification is causing higher and higher levels as you move up in the food chain. Another example here, mercury concentration in water, which is taken in by algae, which is taken in by algae-eating insects, which is taken in by insect-eating insects, which is then taken in by insect-eating fish, fish-eating fish, and finally humans, where now the mercury concentration continues to rise because of that biomagnification. So some of the common toxins that we see that biomagnify include PCBs, which are polychlorinated biphenyls, mercury, and then DDT, as we talked about, that pesticide. An example or a case study is that Mountain Lake PCBs are found in Mountain Lake, which, which were found in the kokanee salmon, which are stocked there. They were stocked more than 30 years ago, and they have two persistent organic pollutants, the PCBs and dioxin, according to the Washington State Department of Ecology, which causes a threat not only to those species, obviously, but to the humans that are eating the salmon. So that'll be the end of this unit. We're going to be looking at the end of this section. We'll be looking at Section 9 next, solid waste disposal, and then we'll continue.